It says this: Newton's law of cooling models the temperature, T, of an object over time in minutes using this function. Where T, this is T naught or T0. It's just talking about the time, the initial time, initial temperature, I'm sorry. And Tm is the temperature of the medium. K is the constant for the medium. A cookie was taken from the oven and placed in a cooling rack with surrounding air temperature of 20 degrees Celsius. After 5 minutes, the cookie cooled to 48 degrees. If K is this, what is initial temperature? Well, so all you have to do is plug in, and honestly, you could insolve this. It says the surrounding air temperature of 20. So that means the medium here is 20 degrees. We know that's 20. And it says after 5 minutes, so there's been 5 minutes have taken place, so that would be our T. It cooled to 48 degrees. Now that's what it's cooled to. So time after 5 minutes is 48. So that's going to go here. So 48 equals this. And we also have the medium twice. So that would go there. Now inside here, we don't know what T sub 0 is. That's what we're looking for. But we do know over here that we have negative K is 0.35, and we also know that T is 5 minutes. So you could insolve this, which is probably the easiest way. I'm just going to write down insolve, do that, comma, x, close your parentheses. Let's just go ahead and get what the answer is, and then I'll show you the algebra behind it. So you would, from new document here, add a calculator. You go to menu 3.1, which is menu algebra, numerical solve, and then you would type in the values. So the equation was 48 equals 20 plus parentheses, and let me go check it again. Now we don't know what T sub 0 is, so I'll put an X in that place. And so over here, what I need to actually do, if I want to insolve this, is I want to put an X right there because I don't know what that is. So that would actually be our X. X minus 20. And then on the outside of the parentheses, we have the E over here to the power of negative. It was 0.35, I believe. Let me check. Yep, times 5. Now, after you type in everything, you have to go outside and you press comma X. That's what we solve for. So it says the temperature is 81.13. Not 81, 181.13. 181.13. And it doesn't say what to round to, so I'll just write it that way. So 181. I've already forgotten. 13. And then you just fill in all your bubbles underneath. Now, if you wanted to solve it by hand using good algebra, not just the calculator as a tool, what we would do is we would take these values and we would start to try to isolate everything. So I'd have 48, try to isolate the variable rather, plus x minus 20 e to the power of negative 0.0355. Okay, so I'd first try to isolate some things. I would subtract the 20 here, and not only would I do that, I'm also going to multiply that out and figure out what that equals, because I'll have x minus 20 times this value. Now let's go see what this is. If I go to the calculator, you would type in e to the power of negative 0.35 times 5, press enter, and that is going to be 0.17, I'll go 174. We'll go 174 for that, times 0.174. And let me check one more time to make sure I didn't make a mistake there. Yeah, 174. So now to solve, if I want to get the x by itself, again, since these are multiplying, I would divide and do opposites. That's how you always get things by itself. So I would divide that. Now since I have the exact value, stored in the calculator, this ought to be easier just to go 28. Come on, 28 divided by this. That'll give me an unrounded and a better answer. So it's 161.13. 161.13. 161.13 equals, Now those went away, so it was x minus 20. Last step is we would just add 20 to that. And we see that we're going to end up with the exact same answer as what we had before by end solving. 181.13 would equal x.